Good morning, everybody. I'm aware of at least two methods of solving this particular problem. One would be just to do a substitution right here. In other words, you could write this as x times, what do we got here? 3 minus x equals to 7. Now, if you look at this, if you actually take this, I'm not going to go any further than here, but you end up with complex solutions to this. So you end up with a pair of complex conjugate solutions to this particular equation, and then you'd have to raise those complex solutions to the fifth power, which isn't terribly difficult, but I'm going to just present an algebraic way. And again, this way right here is just replacing y with 3 minus x and then getting a quadratic, okay? The approach I'm going to adopt is just using the binomial expansion, which this is tedious, and so it's up to you to decide. I like doing it algebraically. I don't know why. Just a little more familiar with that method. It seems slightly easier, although you may disagree. But anyway, the binomial expansion and factoring gives this condition right here. Notice that when you do the binomial expansion, you can factor out 5xy from these four middle terms here, okay? And so you get down to this position where you have enough givens here, and you can see, let me see if I keep it on the same, yeah, I got it on the same screen here. Notice that we use the given values here, x plus y is equal to 3 and xy equals 7 right here. We algebraically isolate the object we're trying to evaluate in this fashion, okay? And we get to this stage right here numerically. But notice that all that's left here is x cubed plus y cubed. Everything else is a constant. We would know what x to the fifth plus y to the fifth is if we could evaluate x cubed plus y cubed. Well, it's this is iterative in the sense that you can use the binomial expansion again. I didn't write it in here, but this is just the binomial expansion. And in a similar fashion, you can determine exactly what x cubed plus y cubed is equal to. It's negative 36. Okay, so we did a double dip on the binomial expansion. We get to this point right here, folks, and this is just pure computations right here. This would be 243 minus 35, and I believe this is 42 minus 36, which is 6, so this is times 6, okay, right here. Okay, but this is equal to 243 minus 210. This is 210 right here, right? And so I'm getting 33, okay? And again, I just evaluated this left-hand side, and so 33 is our answer, folks, and it's equal to this guy right here, okay? So anyway, it seems like a lot of work to do it this way, and perhaps it is. I'd like to know people who think about computational efficiency. First, you'd have to solve this. Again, as I mentioned, you discover you get complex conjugate solutions with irrational coefficients. Then you have to raise them to the fifth power. And so people who are adept at doing the complex exponentiation, but it's probably easier just to solve, I guess, in terms of number of steps, but then you're stuck with these irrational complex numbers, and you have to elevate them to the fifth power. If you're skilled at that, then that's cool. But I just like this way because a lot of that gets hidden. Even though this is kind of a burden to go through all of this, it's not. I think it's tedious either way you go. So anyway, I don't know what you guys think. But anyway, this is the solution, and that's all. Let me come up here. It's equal to 33. Okay. Good day.